Well, hello there folks, I hope you're doing well. In this video, we're going to be going through chapter 8.1, the Pythagorean Theorem. So, hopefully you have your textbook ready to go, or your workbook ready to go, and you'll find this on page 214, and we are talking about, of course, the Pythagorean Theorem. So, of course, once again, we will start with the try these. Hopefully you're familiar with a calculator and how to find your square button. So first off is 21 squared. So it says calculate 21 squared, and 21 squared is 441. So first thing there, 441. The second one is 3.2 squared plus 2.3 squared. So I'll put that once again on my calculator. 3.2 squared plus 2.3 squared gives me an answer of 15.53. 15.53. The second one, and the third one and the fourth one, we're going to have to round, you can tell, because it has the equals with the dot over it, which means approximately. So the square root of 12 is approximately 3.46. So on your calculator, 3.464101615. It's an irrational number, which means it will never end. Finally, the last one, I'm going to have to make sure that I use my brackets properly. So it's the square root of bracket 9 squared minus 4 squared, close bracket, gives me an answer of approximately 8.06. Once again, rounding. From 8.06225778, etc., etc., etc. So let's just practice doing squares in your calculator. Now let's get into the main thing, the Pythagorean Theorem. Marie-Pierre and Sam are doing a bottle drive for their hockey team. Marie-Pierre will go to the houses in regions A and B, and Sam will cover region C. Will Marie-Pierre and Sam cover the same number of blocks? How do you know? Well, assuming these lines all mean blocks, Marie-Pierre is going to cover 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19, 20, 21, 22, 23, 24, 25. I've miscounted somewhere. 9 plus 16, 25. And Sam, we've got a 5 by 5. I really should have just done it that way. So we have 3 by 3, which is 9, 4 by 4, which is 16. 9 plus 16 is equal to 25. Sam here has a 5 by 5 block group, which is also 25. So they're both going to cover 25 blocks. Yes. Marie-Pierre covers 9 plus 16, or 25 blocks. And Sam covers 25 blocks. Now you may wonder why we're doing this. It'll become very clear in a moment, hopefully. How many units long is the side opposite the right angle? That's a super confusing way to say it. So the side, this is our right angle here, of course. The side opposite the right angle is this side there. How many units long is it? How do we know? Well, okay, it's 1, 2, 3, 4, 5. 5. Because it's one side of the, I don't even know what to call it, the 5 by 5 square. It is one side of the 5 by 5 square. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the two outer sides called legs. So, the hypotenuse is the side of a right triangle that's opposite our 90-degree angle, or our square angle, so that's side C. Always going to be side C in the ways that we do it. And then side A and B are called the legs. So we have leg A and leg B. So the length of C is equal to the square root of A squared plus B squared. You may have also heard it as in the Pythagorean theorem, a squared plus b squared is equal to c squared. And it's named after Pythagoras, an ancient Greek mathematician who proved this a long, long time ago. So let's, using that information, particularly this formula right here, let's do a couple of example questions. Example number 1. How can you show the Pythagorean theorem using a geometric model? The solution. First of all, draw a right triangle on grid paper. So now I have my grid paper all ready to go. Draw a right triangle. So let me just use the ability to do straight lines as well. There we go. So a right triangle. Beautiful. What is my next step? Oh, I should show that it's a right triangle by drawing the little square in the bottom. Okay, there we go. Now it's definitely a right triangle because we've showed it's a right triangle. Next thing, let's bring this up again. So now I'm going to draw a square. So to draw a square, I'm going to need it to go. Wow, that is a really, I should not have drawn such a huge triangle. So it's got to go something like that. So I am going to, I can't fill it in like that. Okay, that's fine. That's fine. So I will draw a square there. Perfect. Got a square there on that leg. And I will draw a square this way. 1, 2, 3, 4, 5, 6. There we go. Okay, so I've finally drawn the squares. You definitely, if you're going to do this, make sure you use a smaller triangle. Make your life a little easier. Okay, so I'm going to cut out the squares on the legs and then rearrange and cut the 2 squares as needed to fit them on the square of the hypotenuse. What am I going to notice? Well, let's see if I can do this with a computer. I don't have a lot of faith in my ability to do so, but we might just get lucky. So the first thing I'm going to do is cut out this huge square here. Cut it out, and now we're going to paste it. And we're going to need to rotate it. So I will put it up here and give it a little bit of rotational action. And if I were smart about this, I could have measured the angle and use that angle to rotate it properly. But I mean, that looks reasonably close. So if you notice, this does not fit on my page anymore. So I am going to move these 2 layers down. Wow, this is some exciting math going on here. There, okay. So that has fit beautifully. And now, I will go and grab this one right here. So I will grab that part right there. And I'm going to paste it as a new layer. And once again, I am going to rotate this one about 25 degrees. Hoping for the best. Okay, so if you look, it doesn't quite fit. It's only about 1.5 squares long. So the next thing I'm going to need to do is cut it into 1.5 square strips. Obviously, this is much easier on paper. So So when you do this, if you do this, I definitely recommend doing it this other way. So, and within some sort of error, of course, because it's not going to be perfect, you will find, yeah, so it's a little iffy. Not perfect, but more or less, those two legs were able to fit into the two squares on the left leg and the bottom leg were able to fit into a square along the hypotenuse. Okay, enough of the arts and crafts, though. Let's answer the question. So cut out the squares, blah, 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 blah. What do you notice? What we noticed was the squares from the legs filled a square oh, you know what? There was supposed to already be a square on the hypotenuse. Filled the square of the hypotenuse. Try it several times using a different right triangle each time. You go right ahead. I am not going to be doing that. But what you will notice, if you do it a whole lot of times, it always works. Do you think this will be true for other kinds of triangles? Try drawing different triangles and checking the relationship. What do you notice? I'll save you the trouble of doing that, and it doesn't work. It only works for right triangles. There are more difficult rules for other triangles. So it doesn't work for a non-right triangle. So if I got my scalene, my isosceles, my equilateral, well, I guess scalene would be a right triangle. If I have a non-right triangle, it's not going to work. The hypotenuse is always going to be the longest side. We know that because the length of the side is going to be the square root of the sum of the legs. So if I add something together and square root it, it's always going to be bigger than anything else. It has to be, because I'm adding positive numbers to it. So example number 2, how can you tell if WXY is a right triangle only using a ruler? Well, if it follows the rules, then first of all, I'll mark that this is my right angle, then my YW has to be the length that is the square root of YX and XW. So the first thing we need to do is measure the sides. And when I do that, I find that YX is 4 centimeters long, XW is 3 centimeters long, and YW is not 2 centimeters, 5 centimeters long. So what are the measures of the sides? Yeah. See that right there. What is the sum of the squares of the two shorter side lengths? So it's saying what is 4 squared plus 3 squared? Well, 4 squared plus 3 squared is the same as 16 plus 9, which we have already seen. 16 plus 9 is 25. What is the length of the longest, or what is the square of the longest side length? 5 squared is equal to 25. Compare your answers to part B and C. What does this mean? It's a right triangle. I guess I shouldn't have written that square there because I wasn't sure. But it's a right triangle. This is the 3, 4, 5 triangle. It's the most basic right triangle. And you'll see it, I mean, a lot when you're learning about this stuff. And that's it. So the basics. The most important thing to get out of this is the fact that a squared plus b squared, so the square of the legs, is equal to the square of the hypotenuse in a right triangle. The hypotenuse is the side of the right triangle. That's the longest. It's the one that's across or opposite the 90-degree angle. And A and B are the legs. Hopefully this was clear. If you have any questions, let me know. Hope you have a fantastic day. I'll talk to you later.